Imagine a machine so fast that it blurs the line between a train and a fighter jet. This is not a scene from a science fiction movie set in the year 2100. This is the reality currently unfolding on the tracks of China. The world is watching in a state of collective disbelief as a new era of transportation is born. But before we start, don't forget to subscribe to our channel. A super maglev train capable of hitting a mind-bending 620 miles per hour. To put that into perspective, most commercial aircraft like the Boeing 737 or Airbus A320 cruise at speeds between 500 and 550 miles per hour. This means that for the first time in human history, we have built a ground-based vehicle that can actually overtake a plane mid-flight. This is a monumental shift in the global technological landscape, a wonder of engineering that has effectively rewritten the future of how humanity moves across the planet. But the real question that everyone is asking is, how is this even physically possible? How can a massive structure weighing hundreds of tons move at the speed of sound without vibrating into pieces or flying off the rails? The journey to this achievement was not paved with easy victories. Once upon a time, the global perception of Chinese rail technology was average at best. People thought that as long as the trains arrived on time, it was enough. But deep within the strategic planning rooms of the Chinese government and the high-tech laboratories of their top engineers, a dream was taking shape. They didn't want to just build a better train. They wanted to build the fastest machine on Earth. They envisioned a future where the ground could compete with the sky, and they were willing to bet billions of dollars to make it happen. When the project was first announced years ago, the international community responded with skepticism and even mockery. Experts argued that the energy required to push through air resistance at such speeds on the ground would be impossible to manage. They said the friction would be too great and the safety risks too high. But the engineers of China did not blink. They turned their backs on the critics and focused on a technology that had been a curiosity for decades but had never been mastered on this scale. Magnetic levitation, or maglev. The brilliance of this train lies in the fact that it doesn't actually run on anything. It floats. By utilizing the fundamental principles of electromagnetism, the engineers managed to eliminate the greatest enemy of speed, friction. In a traditional train, the wheels grinding against the metal rails create heat and resistance, which acts as a physical ceiling for how fast the train can go. China's new maglev destroys that ceiling by using incredibly powerful magnets that repel the train from the track, lifting it nearly 2 inches into the air. When the train is levitating, it is essentially flying in a magnetic cradle. Without the friction of wheels, the only thing holding the train back is air resistance, and that is where the genius of aerodynamic design comes in. The train's body is shaped like a needle, slicing through the atmosphere with such precision that it creates almost no turbulence. This allows it to reach 1,000 kilometers per hour, which is nearly 150 kilometers per hour faster than the average cruising speed of a passenger jet. But the speed is only half of the story. Traveling at 620 miles per hour on the ground presents challenges that pilots at 30,000 feet never have to deal with. When a plane flies, it is surrounded by thin air and vast open spaces. A train, however, must stay perfectly balanced just inches above its track while moving through the much denser air at sea level. To solve this, the Chinese team developed a revolutionary guidance system that uses artificial intelligence to adjust the magnetic field thousands of times per second. This ensures that even at maximum velocity, the ride is as smooth as silk. There are no jolts, no rattles, and no noise. Passengers inside describe the sensation not as traveling, but as sliding through time and space. You can place a coin on its edge on a table inside this train while it's moving at top speed, and the coin will not fall. This level of stability is what separates a world-class engineering marvel from a mere experiment. China has effectively proven that the future of travel isn't necessarily in the clouds. By bringing jet-like speeds to the ground, they have created a transport system that is more efficient, more comfortable, and infinitely more accessible than aviation. There are no long boarding processes, no luggage weight limits that resemble a workout, and no turbulent weather to worry about. This train moves forward with an aerodynamic fury that ignores the wind and rain, cutting through the air like a hot blade through butter. It is a testament to human willpower and the refusal to accept the word impossible. While the rest of the world was content with incremental improvements to existing tech, China took a leap into the unknown, investing in superconducting magnets and vacuum-sealed testing environments to ensure their dream became a reality. Today, the 620 miles per hour beast is no longer a dream or a prototype. It is a symbol of a new world order in technology, showing every other nation that if you have the courage to innovate and the resources to back it up, you can truly outrun the wind. This is the story of how China decided to stop following the world and started leading it into a future where the ground beneath our feet is just as fast as the sky above our heads. Now, let's peel back the metallic skin of this beast and look at the magic that makes the impossible possible. You've heard the term maglev, but what does it actually mean to defy gravity on a 1,000-ton scale? To understand this, you have to forget everything you know about traditional trains. There are no engines roaring, no pistons pumping. And most importantly, as we've mentioned, there are absolutely no wheels. This is magnetic levitation taken to its absolute extreme. The core concept is deceptively simple, but the execution is pure 22nd century science. Imagine the entire track as a giant, intelligent electromagnetic bed. Inside the train's undercarriage and embedded within the guideway are thousands of sophisticated superconducting magnets. When the power surges through these coils, a massive repulsive force is generated. This isn't just a gentle push. It's a controlled explosion of magnetic energy that lifts the entire train 2 inches into the air. At that precise moment, the train becomes a ghost. It is no longer tethered to the earth. It is floating in a state of perfect equilibrium. But floating is only half the battle. How do you propel a floating skyscraper to 620 miles per hour? This is where the linear motor system comes in. Instead of a rotating motor turning a wheel, the magnetic fields themselves act as an invisible wave. The magnets on the track pull the train from the front and push it from the back simultaneously, creating a continuous surge of acceleration that feels less like a train ride and more like being launched from a giant, silent electromagnetic slingshot. Because there is no mechanical contact, there is zero friction. And where there is no friction, there is no heat, no wear and tear, and virtually no limit to how fast you can go. This is the real reason why China has left the rest of the world in the dust. They didn't just build a faster train. They mastered the art of terrestrial flight. But don't be fooled. Achieving this level of stability at such violent speeds was a nightmare for engineers. When you are moving at 1,000 kilometers per hour, the smallest gust of wind or a microscopic bump on the track could lead to a catastrophe. To prevent the train from vibrating itself apart, the Chinese research teams developed a real-time AI stabilization system. This system adjusts the magnetic flux thousands of times per second. If the train leans even a fraction of a millimeter to the left, the magnets on that side instantly increase their power to push it back into a perfect center. It is a constant, invisible dance between electricity and gravity. Furthermore, they had to solve the air wall problem. At 620 miles per hour, the air in front of the train becomes as hard as a brick wall. To pierce through this, they utilized a vacuum-inspired aerodynamic design and specialized skin coatings that reduce skin friction drag. Every bolt, every panel, and every curve of this train has been tested in high-speed wind tunnels to ensure that it slices through the atmosphere like a hot knife through butter. Now, let's step inside. If the exterior of the train is a masterpiece of physics, the interior is a masterpiece of human comfort. Forget the cramped, noisy cabins of a commercial airplane. Stepping into this maglev is more akin to walking into the lobby of a high-end boutique hotel in Dubai. The first thing that hits you is the silence. Because there are no wheels hitting tracks and no jet engines burning fuel, the internal cabin is eerily quiet. Even at its top speed of 620 miles per hour, the only thing you hear is the faint hum of the advanced climate control system. The design language inside is futuristic minimalism. We are talking about wide, spacious corridors bathed in soft, recessed LED lighting that adjusts its hue based on the time of day to prevent jet lag. The windows are massive, reinforced smart glass panels. Unlike a plane where you see nothing but clouds, here you see the world blurring past in a psychedelic streak of colors. But thanks to the incredible stabilization, there is no flickering and no motion sickness. You can literally place a glass of water on your tray table at 1,000 kilometers per hour, and the surface of the water will remain perfectly still. Not a single ripple. The seating is where the future of travel truly becomes a reality. These aren't just chairs. They are ergonomic command centers. Each seat is upholstered in premium, breathable materials and features zero-gravity reclining technology, inspired by NASA. This positions your body in a way that distributes your weight evenly, making you feel weightless as you travel. Every passenger has access to an individual touchscreen interface that controls everything from the seat's built-in massage functions to the transparency of the window next to them. There are high-speed Wi-Fi 7 connections, wireless charging ports integrated into the armrests, and even localized sound bubbles that allow you to listen to your music or movies without headphones, yet without disturbing the person sitting right next to you. The dining car is another level of luxury entirely. It's a sleek, modern cafe serving gourmet meals prepared by top-tier chefs, where you can enjoy a hot espresso while the landscape of China vanishes behind you at the speed of a bullet. It's not just a commute, it's a sanctuary. China has proved that you don't have to sacrifice comfort for speed. They have created a way to travel that is faster than a jet, smoother than a limo, and more sustainable than any other vehicle on the planet. But this journey wasn't always so smooth. Behind this glittering success lies a decade of failed tests, melted magnets, and billion-dollar gambles that almost bankrupted the project. While the world stares in awe at the finished masterpiece gliding through the Chinese landscape, few realize that this 620 miles per hour miracle was forged in a furnace of failure, frustration, and near-impossible engineering hurdles. Building a train that outruns a jet isn't just a matter of bigger magnets or more electricity. It is a violent battle against the fundamental laws of physics. To make this dream a reality, Chinese scientists and engineers had to confront obstacles that had previously defeated the brightest minds in Europe and Japan. This was a project where the stakes were measured in billions of dollars and where a single decimal point error in the blueprints could lead to a catastrophic disaster at 1,000 kilometers per hour. The journey from a mere blueprint to a functioning Leviathan was a decade-long war against vibration, heat, and the crushing weight of air pressure. The first and most terrifying challenge was the stability paradox. In the world of high-speed rail, speed is your friend until it becomes your greatest enemy. As the train's velocity increases, so does the intensity of the vibrations. At 620 miles per hour, a vibration that would be a minor annoyance in a car becomes a force strong enough to tear metal apart. In early tests, the prototypes would begin to shake so violently that the magnetic levitation would nearly fail, bringing the train dangerously close to a touchdown on the track at supersonic speeds, an event that would result in an instant explosion of sparks and molten steel. To solve this, engineers had to reinvent the very concept of a track. They realized that traditional concrete wasn't precise enough. They had to develop a micro-level alignment system, checking every single inch of the guideway with laser precision to ensure it was perfectly straight down to the thickness of a human hair. The aerodynamic nose of the train also underwent hundreds of redesigns. If the shape wasn't perfect, the air wouldn't just slow the train down, it would lift it up like an airplane wing, causing it to flip over. The second massive hurdle was the heat crisis within the magnets themselves. To lift a massive, passenger-filled train and keep it floating while moving at the speed of a bullet requires an immense amount of electromagnetic energy. In the beginning, the powerful magnets used in the prototypes would generate so much heat that they risked melting their own housing units. Traditional cooling systems were too heavy and inefficient. This led to a breakthrough in superconducting technology. The engineers had to develop a new generation of magnets that could operate at extreme temperatures without losing their power or catching fire. There were months where every test ended in smoke and melted components. The government and the public began to wonder if the billions spent were being thrown into a bottomless pit. But the scientists persisted, eventually creating a closed-loop cooling system that allowed the magnets to maintain a massive repulsive force while staying cool enough to touch. This was the turning point that transformed a dangerous experiment into a viable mode of transport. Then there was the pressure wall. At sea level, air is much denser than at the high altitudes where planes fly. When a train moves at 620 miles per hour near the ground, it creates a massive shockwave of compressed air in front of it. For the passengers inside, this would feel like being inside a submarine that is surfacing too fast. Their ears would pop painfully, and the sheer noise of the wind outside would be deafening. To overcome this, the engineers had to seal the train like a spacecraft. The interior is a pressurized cabin where the air pressure is controlled by advanced computers to remain constant, regardless of the speed or the tunnels the train enters. They also had to invent new types of acoustic glass and vibration-dampening alloys to ensure that the roar of the wind remained a faint whisper inside the luxury cabin. Beyond the physics, there was the psychological and financial pressure. Thousands of engineers lived at the testing sites for months at a time, away from their families, working under a government mandate that demanded nothing less than global dominance in technology. Every failed test was a national headline. Every setback was analyzed by critics worldwide. There were times when the magnetic fields would fluctuate unexpectedly, or the power grids would fail under the massive load of the train's acceleration. But China's strategy was one of trial by fire. They didn't just study the problems. They built, broke, and rebuilt until the technology yielded to their will. This wasn't just a project about transport. It was a project about national pride and the proof that human courage, when backed by limitless resources and relentless innovation, can force the impossible into reality. Today's smooth ride is the result of those thousands of sleepless nights and the stubborn refusal of a generation of engineers to accept defeat. They didn't just build a track. They built a bridge to a future that everyone else said was a fantasy. The moment China's 620 miles per hour maglev roared into existence, the geopolitical landscape of technology changed forever. This wasn't just a win for one nation. It was a loud, metallic wake-up call to every other superpower on the planet. For decades, countries like Japan, Germany, and France sat comfortably on their thrones as the masters of high-speed rail. They believed their bullet trains and TGV networks were the pinnacle of human achievement. But China didn't just join the race. They moved the finish line to a different continent. Now, a global scramble has been ignited. In the boardrooms of Tokyo and Washington, D.C., and the research labs of Berlin, the question is no longer, how do we make trains faster? But, how do we survive a world where China moves faster than the wind? The Shinkansen in Japan, once the gold standard of speed, is now under immense pressure. Japanese engineers, known for their perfectionism, are now working at a feverish pace on their own L0 series maglev, aiming to reclaim their lost glory. They are pushing the limits of superconducting materials, trying to find a way to make their trains even more efficient and stable than the Chinese model. It is a technological arms race where the weapon is speed, and the prize is the future of global commerce. In the United States, the impact has been a mixture of awe and urgent realization. For too long, the American rail system has been viewed as a relic of the past, a slow and aging network that couldn't compete with the efficiency of domestic flights. But the sight of a 1,000 kilometers per hour train has sparked a new conversation in the halls of Congress and among Silicon Valley's elite. Projects that were once dismissed as fantasy, like the high-speed links in California and Texas, are suddenly being viewed as national security priorities. The message is clear. If the West doesn't innovate, they will be left standing on a dusty platform while the future glides past them at 620 miles per hour. Europe, too, is feeling the heat. From the high-tech corridors of France to the engineering hubs of Italy, there is a renewed push to invest in vacuum tube technology and maglev systems. They realize that in a world where time is the most valuable currency, a train that can cross a continent in a few hours is not a luxury. It is a necessity for survival. But this story isn't just about speed and national pride. It's about the very survival of our planet. One of the most incredible aspects of this maglev revolution is its profound impact on the environment. We live in an age where the carbon footprint of aviation is under intense scrutiny. Airplanes, for all their speed, are massive polluters, burning thousands of gallons of fossil fuels and releasing toxic gases into the upper atmosphere. China's maglev offers a green miracle because it runs entirely on electricity, often sourced from massive solar and wind farms. It produces zero direct emissions. It is a silent, clean, and sustainable alternative to the roaring engines of a jet. Imagine a world where you can travel across a country at jet speeds without contributing to the melting of the polar ice caps. This is the promise of the maglev. It isn't just a faster way to travel. It is a way to travel that doesn't cost us the Earth. It is the first time in history that superspeed and sustainability have been combined in such a powerful way. The human experience of this technology is perhaps the most transformative part of the story. Early passengers who have stepped off this train don't talk about miles per hour or magnetic flux. They talk about the feeling of a dream becoming real. They describe looking out of the smart glass windows and seeing the world not as a series of obstacles, but as a beautiful, blurred tapestry of color. They talk about the psychological shift of being in one city for breakfast and another, 1,000 miles away, in time for a mid-morning coffee, all without the stress of airport security or the turbulence of the skies. This technology is shrinking our world. It is making our planet feel more connected, more accessible, and more unified. It is breaking down the barriers of distance that have defined human civilization for millennia. As we look toward the next decade, we must ask ourselves, what comes next? If we can reach 620 miles per hour today, what will we reach tomorrow? Some are already talking about hypermaglevs in vacuum tubes that could potentially reach 2,000 or 3,000 miles per hour, moving people between continents faster than a rifle bullet. What started as a dream in the minds of a few Chinese engineers has evolved into a global movement that is redefining the limits of human potential. China has proven that the impossible is simply a challenge that hasn't been solved yet. They have shown that with enough will, enough resources, and enough courage to fail, we can truly conquer the laws of physics. This train is not just a collection of magnets and steel. It is a message to the future. It is a declaration that the era of slow movement is over. The future is here, it is silent, it is green, and it is moving at a speed you can barely imagine. So the next time you look at the horizon and see a flash of silver on the ground, remember, it's not a plane, and it's not a mirage. It is the new heartbeat of our civilization, running on tracks that lead to a world without limits. If you want to stay on the cutting edge of the technology that is changing our world, make sure you are part of our journey. The future is moving fast. Don't get left behind.